In lesson 4, we're going to be looking at distances and circles and building the equation for a circle. So let's take a look at this picture here. So ultimately what we want to do is figure out the length of PQ, which are these 2 points here. And so we've looked at finding distance using Pythagorean theorem between 2 points. But we've always been able to kind of count using grids here, okay? And here's the scale. But we've always been able to kind of count the length and width, or the base and height of the triangle produced. So how do we do it in a case like this? And in your textbook, you see Andre talking about this, knowing that he can find the distance between 2 points by drawing a right triangle like pictured, but isn't quite sure how to do it without the grids behind it. So see if you can come up with something. Can you come up with a strategy to figure out the leg lengths here so that you can use the Pythagorean theorem and then actually calculate it? All right, so when we're looking at this, we don't have the grids to count here, right? But how can we figure out how long this is? Okay, so when we're talking horizontally, if we were counting this, this is movement in the x direction. So we're looking at where does this point fall here? Okay, and where does this point fall here? And then we're trying to figure out this distance, right? So that's really just the x coordinates that we're looking at for that width. So we've got an x coordinate of 8 all the way up to 53. So one way you can figure out how far it is between those is the difference of those two numbers or subtracting it, and that will give you the distance there between 8 and 53. So getting 45 for that length there. Then how do we look at the height? So how do I find the height in this? And so the height is here. So what is this value? Okay. And what is this value and the distance between those? So this top height is 22. And this bottom height is 12. And then what's the distance between those? And that you just might know is 10. Okay, again, you could subtract those 22 minus 12 to figure that out. Then calculating using Pythagorean theorem here. So looking at our PQ squared. So that's our C value. So PQ squared equals 45 squared plus 10 squared. So PQ squared equals 2025 plus 100. Which is 2,125. And then we will square root that. So PQ will be the square root of that, which is about 46.1. So finding the distance between the two values, taking a look at the length or the horizontal movement being the distance between the x values, and the height being the distance between your y values. So let's take a look at how this is going to play out on a circle, because we said we're talking about circles today. So here we have a circle. A couple of things about this circle is that its center is at 610 and its radius is 17. Remember, a radius just means the distance from the center to any point on the circle is 17. Okay, so the radius is the distance from the center to the edge of the circle. And that's going to be 17 in this whole circle. So take a look at point 1425. Okay, do you think that this point is on the circle? So we could kind of estimate. Here's 14, go to 25. So is that point on the circle or is it not on the circle? What do you think? How about 22.3? So do you think those 2 points are on the circle or are they not? And could you verify it? So could you prove to somebody that your answer is correct? Your guess is correct or incorrect? So that's what we're going to be looking at here is, can we actually verify that these 2 points are on the circle? So remember, the definition of a circle is the set of all points a specific distance from the center. And in this case, that specific distance is 17. So what we need to see is we need to figure out the distance between 610 and 1425 and see if that's 17. If it is, this point is on the circle. If it's not, then the point is not on the circle. So remember that we can create this right triangle to figure out the legs and then do the Pythagorean theorem to find the length of this. Okay, so this is what we're trying to calculate here, is this, and I'm just going to call it D for distance, the distance between these 2 points. We want to see if that's 17. So first we have to figure out how far apart these 2 x values are to figure out the length here. So we've got 6 and we've got 14. I'm going to switch colors. Well, this is fine. 6 and 14. So 14 minus 6 gives us 8. Comparing those x values. And then the height of this triangle, we'll be looking at the y values. Okay, it goes from 10 to 25. So that's going to be 15. And again, you can do 25 minus 10 to get that. And for this x value, we did 14 minus 6 to figure out how far apart they are, compared those x's and compared the y's. So now we see the legs here. So we're going to do d squared equals 8 squared plus 15 squared to figure out what this distance, or what this, the distance between these 2 points is. So 64 plus 225. So d squared is equal to 289. Square root that, and you get d equals 17. So the distance between these 2 points is 17 units, which is your radius. So that means this is on the circle. And then we'll repeat that process with 22(3). So I'm just going to kind of clear out the screen here. And we can take a look at this new one. So this is what we're trying to do on this one. Again, figure out the distance between these 2 points and see if it's 17. So the length here, okay, or this horizontal line, again, we'll compare the x's. So 6 to 22. Okay, so 22 minus 6, which is 16. And then the height here, comparing the y's. So 10 and 3, what's the difference between those? And that's 7, which again, you can do 10 minus 3. So then we'll figure this out. So d squared is equal to 16 squared plus 7 squared. 16 squared is 256. And 7 squared is 49. So add those together and you get d squared equals 305. And then you can square root that to get that d equals 17.46, which is not equal to 17. So that does not equal the radius. So this one is not on the circle. Okay, so that one is close to being on the circle, but not quite. It's a little bit too far away, 17.5 units instead of 17. All right, so in general, so now I've given you, we've looked at specific ordered pairs, okay, specific ordered pairs, but let's generalize this, okay? So generalize the process of what we did. So remember, we'll need the length of this horizontal distance. So how did we figure that out? Remember, it was comparing the x's and looking for the distance between them, Okay, and the distance between them is subtraction. So x minus 6. Remember, this was, 20 or 14 up here. So we did 14 minus 6 for this one. Okay, or in this case, it was 22 and 6. So we subtracted 22 and 6 to get that length. And then what do we do for the height? So this height, remember, is the y coordinates, okay, that vertical distance. So we compared the y coordinates here and found the distance between those, which again is the difference. Subtract them. Okay, so y minus 10 will give you the height of this triangle. And then we called this length between those 2 points d for distance. And we just checked that. Okay, so we did Pythagorean theorem and we looked at d squared and we squared the legs. Okay, so in this case, this horizontal leg is x minus 6 squared plus then our other leg, which is y minus 10 squared, and solved for d. And actually what we wanted is d to be equal to the radius of that circle. So you could put an r there as well. If that was equal to our radius, then that point was on the circle. Okay, and so maybe I'll just leave this as d. And I'll say then if d equals r, the point is on the circle. If d does not equal r, then the point is not on the circle. All right, so let's take a look here. Let's write an equation that would allow us to test this point. Okay, so what would we do to test this point and see if xy is on this specific circle? So we've got the center labeled at 3, 6. And then we've got that point labeled as xy. So we would want to be looking at, and you can label kind of whatever you want. Again, if you want to name this, if you want to actually put the radius in here, I'm just going to call this D because I'm checking that. Okay, what do I want this to be? Actually, I'm going to name it 13. Okay, so this should be 13. And then we'll name these other lengths. So remember the horizontal compares your x's, and it's kind of hard to see, but that's a -3 there. But so compare those x's. So it's going to be x minus that -3 for that length. And then the y, or the height, is going to compare those y's. So y minus 6 for that height. So if we create this equation, okay, our distance should be 13. So 13 squared should equal, so that's our c squared, right? Should equal our legs. So x minus a -3 squared plus y minus 6 squared. So there's your Pythagorean theorem. Okay, so your c squared should equal a squared plus b squared. So here's your a and your b, and then your c. So if a point works in there, then it's on the circle. And works, by works, I mean that the two sides equal. Okay, so you get this distance squared is the 13. Okay, so that your radius or your distance are the same. So now let's test this 0.91 in here. So 13 squared should equal, okay, when we plug in, and I'm just going to leave that x blank there, and then the y blank. Okay, so I'm going to x minus a -3 squared plus y minus 6 squared. I'm just going to leave blanks so we can fill this stuff in. So our x coordinate is 9. So we're going to do 9 minus -3. And our y coordinate is 1. So we'll plug that in. And we're just checking if this works. So we're trying to see, does 13 squared equal these? So 9 minus a -3 is 12. 1 minus 6 is -5. 13 squared is 169. 12 squared is 144. Negative 5 squared is positive 25. So 169 equals 169. That is true. So this is on the circle. Okay, it quote unquote works in the equation that we set up. So let's generalize even further. So in this problem, okay, we had a generic point on the circle, but we knew the center. Okay, so they gave us this center was negative 3, 6. We wrote an equation. Okay, how about just in general for the whole thing? So no numbers in here at all. So this hypotenuse in a circle is called the radius. Okay, and then we want to come up with, so again, we're using Pythagorean theorem for this. So c squared equals a squared plus b squared. And we want to come up with expressions for those legs. So hypotenuse we're calling r. Remember that the horizontal length here compares the x values in the coordinate and the center. Okay, so we subtract those x's, that will be the distance here, the horizontal distance. Then the vertical distance compared the y's. Okay, so we did y, we subtracted the y coordinates. So now we'll plug all of this stuff into the Pythagorean theorem. So we'll do the c value squared, the a value squared, the b value squared. So just plug in all of those pieces. So your c value on here is r, because we just call it a radius. Your legs, one of them is x minus h. The other one is y minus k. So we'll square those, add them together. And then you have a generic equation. So you just have, if we just, I would just clean this up and just write r squared equals x minus h. So subtract those x's, plus y minus k. So subtract those y's. And that would be for this circle to check if a point is on the circle or not. Should satisfy this equation. All right, so that is actually the circle equation. So if you remember back to algebra, you have this equation here for a line, y equals mx plus b. So if you remember that back from algebra, that represented any straight line. Okay, m being your slope. Okay, b being your y-intercept. And then you can create any line from that using that formula. That's the same thing, okay, same idea here with a circle. So this is our generic equation for a circle. So anytime you see something like this, it's creating a circle because we're subtracting the x's and squaring them, subtracting the y's and squaring them, and that should equal our radius squared, coming from Pythagorean theorem here. So on your reference chart, go ahead and write the equation of a circle down. H, remember, H and K need to be the center of your circle. It can't just be some random point in the circle. You want to do the distance from the center to the edge. So we're calling our center point HK, our radius R, and then this point is just any point on the circle. So any point on the circle. So x minus h squared plus y minus k squared will equal the radius squared. HK being the center, R being your radius. So if we describe this graph, so it's a circle. So I would say a circle, describing a circle, you would want to talk about the center. Okay, so what's the center of this circle? So the center is 2, -3. And then a circle also is defined by its radius. So how long is the radius? So, and I would count either vertically, horizontally to figure that out. So this could be your radius. So you could just count that 1, 2, 3, 4, 5, 6. So it appears that the radius is 6 here. So let's go ahead and write the equation for it. So now I'm going to leave all of this stuff. So the X and the Y, kind of all this stuff in black here just stays. And then you're going to plug in your information that you know. So you know the center, the H is the X coordinate. Okay, so we're going to take the X minus the H coordinate. So X minus 2. And we're going to do the Y minus the K, which is the Y coordinate of your center. So Y minus -3. And then your radius is 6. Okay, so this would be your equation, and you can leave it like that. You can also just kind of clean it up a little bit if you want to, and you could do X minus 2 squared, and then Y minus a -3 would be Y plus 3. And then 6 squared, you could write as 36. But what does this equation tell us about the graph? Okay, that every point on this circle is 6 units from the center. All right. Well, and it also, I mean, the equation, if we didn't have this, also tells us the center point, right? So we can see the center is at 2, -3, and the radius is 6 if you're just looking at the equation, okay, and didn't have the graph as well. All right, so lesson summary here is this helps us to decide whether a point is on a circle, thinking about the definition of a circle. Is the set of all points a specific distance away from the center? So for this first part, in this diagram, we see a bunch of points here that are the same distance from this point. So we know it's going to be creating a circle here. So we're going to be creating a circle if we connected these points. And we want to decide, okay, if we know all of these points right here are 5 units from the center, is 7, 4 on that circle? So basically, are these 2 points 5 units apart? Okay, so is the point 3, 1 5 units away from 7, 4? So remember, we compared the x's there to calculate that this length here is 4, okay, 7 minus the x coordinate of 3, and this height, okay, is 3. Did Pythagorean theorem. So this was 4 and this was 3. Did Pythagorean theorem to find out that it does equal 5. So this point is on the circle. The point 8, 2, we figured out this was 1, okay, this was 5. Did the Pythagorean theorem. 5 squared plus 1 squared did not equal the radius squared. So this distance is not 5, so it is not on the circle. So then we generalized this into an equation. Okay, so if we're talking about the circle pictured, remember that the center was 3, 1 and the radius was 5. So we kind of plugged that into Pythagorean theorem for the equation for this circle specifically. And then we did it generally. So for any center HK, so the center is HK, so whatever your center point is, X minus the center, the X center, Y minus the Y from the center should equal the radius squared. All right, so hopefully you can derive the circle equation in a coordinate plane and you see how it comes from the Pythagorean theorem. You can practice that on this screen, on this cooldown. Let me just write the equation up for you again. So X minus H, or the X coordinate of the center, Y minus K, the Y coordinate of the center, should equal your radius squared. So write the equation for these 2 circles. If you have trouble with that or are confused, be sure that you reach out to your teacher.